Good morning, students. Welcome to Chemistry Online class. Unit 12 Periodic Classification of Elements, Part 3. Children, today we will study about Mendeleev's periodic table. Children, this is Dmitry Ivanovich Mendeleev. He was a Russian chemist. In 1869, Mendeleev observed that the elements of similar properties repeat at regular intervals when the elements are arranged in the order of their atomic masses. Based on this, he proposed the law of periodicity, which states that the physical and chemical properties of elements are the periodic functions of their atomic masses. He arranged 56 elements known at that time. Let us see the features of Mendeleev's table. Children, this table, it has 8 vertical columns called groups and 7 horizontal rows called periods. Each group has 2 subgroups A and B. All the elements appearing in a group were found to have similar properties. He corrected some elements' atomic masses. Example, the atomic mass of beryllium was known to be 14. Mendeleev reassessed it as 9 and assigned beryllium a proper place, and some columns were left vacant for elements which were not known at that time, and their properties also were predicted. This gave motivation to experiment in chemistry. Okay, students, now let us know about the merits of Mendeleev's periodic table. Systematic study of elements, prediction of new elements, and correction of atomic masses. These are the merits of Mendeleev's periodic table. Children, next let us know about the limitations of Mendeleev's periodic table. It failed to explain the position of hydrogen. Non-metallic hydrogen was placed along with metals like lithium, sodium, and potassium. No place for isotopes in the periodic table. And the increasing order of atomic mass was not strictly followed throughout. In the table, some elements having higher mass were kept before the elements having lesser atomic mass. For example, cobalt, atomic mass of cobalt is 58.9. Atomic mass of nickel 58.7. So these are the limitations of Mendeleev's periodic table. To rectify the limitations in the Mendeleev's periodic table, in 1913, Henry Mosley arranged elements in the increasing order of atomic number. Henry Mosley, through his X-ray diffraction experiments, proved that the properties of elements depend on the atomic number and not on the atomic mass. Hence, the modern periodic law can be stated as follows. The chemical and physical properties of elements are periodic functions of their atomic numbers. Henry Mosley was known as the father of the modern periodic table. Students, this modern periodic table is the extension of the original Mendeleev's periodic table and known as the long form of periodic table. Let us see the features of modern periodic table. All the elements are arranged in the increasing order of atomic numbers. The horizontal rows are called periods. There are 7 horizontal periods are present. So there are 7 periods in the periodic table. Vertical columns in the periodic table starting from top to bottom are called groups. There are 18 groups in the periodic table. Based on the physical and chemical properties of elements, they are grouped into various families. Group 1 elements are called alkali metals. Group 2 elements are called alkaline earth metals. Group 3 to 12 elements are called transition metals. In group 13, boron is the first member. So group 13 name is boron family. Group 14 elements are called carbon family because in group 14 carbon is the first member. In group 15 nitrogen is the first element, so it is called as nitrogen family. Group 16 elements are called as oxygen family because oxygen is the first member of this group. Another name of this group is chalcogen family. Group 17 elements are called as halogens and group 18 elements are called noble gases. Okay children, let us see the difference between Mendeleev's periodic law and modern periodic law. Mendeleev's periodic law was based on atomic mass, whereas modern periodic law is based on atomic numbers. Okay children, in the next class we will study about classification of elements into blocks in modern periodic table. Thank you children.